Okay, start recording. Thank you very much. Okay, so just for posterity, group 1 on the periodic table is the first column. Okay, so it's the first column, and it contains both hydrogen, which is its own little group. You can just call it the hydrogen group. It's only got one member, very exclusive little club. But all of the other metals, all of the other elements in group 1 are metals, and they are called the alkali metals. All of the metals in group 2, okay, so that if you look at the top of your periodic table, you're going to see group 2. All right, and those are called the alkaline earth metals. Now, all of groups 3 through 12 just fit into one group. Those are called the transition metals. So if you see an element and you're like, oh, I've got copper, and copper's like over here somewhere, you'll be like, it is a transition metal. Yes, because that's the section that it's in. So you'll probably want to have this book, your book open to this page while you do this activity, because it's going to ask you what the name of the group is that they belong to. Okay? Now, there's 2 other columns that have names. One of them is the very last column. What are those called? Noble gases. And feel free to turn your book sideways if you're having trouble reading sideways, right? Because that's a little tricky. And then finally, our last vertical, like single column, is the halogens. Okay. Those are our halogens, and those are group 17. So 17 is the halogens, and 18 is the noble gases. Now, what the heck is everything else? Everything else is either other nonmetals. They don't have a specific group, but those are the white ones. We have other metals. And then we have the metalloids. And what we're going to do is on our green periodic table, we are going to draw, do you see this line that looks like a staircase, that dark black line? We're going to draw that on our green periodic table. Okay, so we're going to do it together. Let's go to our periodic table of elements. And the reason we're doing it together is that I want you to practice doing it. You are going to start at the corner of boron. So you're going to start here at the top left corner of boron, and you're going to draw down. And if it doesn't look dark enough, you can kind of scribble up and down a little bit until you get a nice thick line. Once you've gone down, you're going to go across. And then once you've gone across, you're going to go down. And you're just going to keep doing that, making a staircase the whole way down. Once you've done that, if you would like to go get yourself a highlighter, please go do that. They are on top of the broken glass bin right now because I had to move a few things. Okay, so feel free to go get yourself a highlighter. If you would prefer a pencil crayon, I've also got some of those. If you've got your own coloring version, that's good too.
Good job, guys.
If anyone prefers pencil crayons to a highlighter, I've got pencil crayons here. Okay. And we are going to shade in the metalloids because mostly the metalloids are the ones that touch the line. However, there's one that's not a metalloid. So, boron is a metalloid. It touches the line that separates the metals and the nonmetals. And everybody else except for aluminum, aluminum is a metal. Hopefully you guys know that. If I said aluminum and I said, is it a metal or a non-metal or a metalloid, what would you just automatically say about aluminum? It's a metal, right? It looks like a metal. You're used to seeing it as a metal. But all the other ones that touch the line that have two sides, okay, so let's grab that pen again. So silicon is a metalloid. Metalloids have some properties of metals and some properties of non-metals. And we'll go into those details in a little bit, okay? So on the top of the line, we have boron, silicon, arsenic, tellurium. And then to be honest with you, it kind of falls apart down here. We'll keep coloring them in just to be consistent, but astatine is actually really radioactive. It's very unstable. It doesn't really stick around long enough for us to know if its properties are more like nonmetals or more like metalloids. But just to be, for grade 9, I feel like we can just carry on down the line, okay? So those are metalloids. We are also going to color the ones on the other side of the line. So that would be whatever the heck that is, tennessine, I guess named after the state of Tennessee. Polonium. Antimony, which has a weird symbol, SB. Germanium. And now if life were good, aluminum would also be a metalloid because then it would all follow the same pattern, but aluminum is not. Aluminum is a metal. Okay, so we don't shade aluminum because one of the things that you are going to be recording on your lab sheet is, let me just grab this for you here. Not that one. Oh, whoops. That's the one. There we go. You are going to be recording which group it's in. Okay, so this is on your lab recording sheet. You're going to be recording what group it's in. And so that's either going to be the alkali metals, alkaline earth, transition metals, other metals, halogens, noble gas, and nonmetals. So you'll be looking those up on page 4. So if you want to, for yourself, you can say page 4 for those groups. We also have hydrogen, belongs to no group. You can just call it the hydrogen group. And we have metalloids, and they just belong to metalloids. Okay? And we're not going to worry about the signing for clean test tubes because that's going to happen next week. We'll do the chemical testing next week. This week, we're only looking at physical properties, things where we don't actually have to change the matter. Next week, we're going to look at chemical properties where we actually make changes to the matter. Okay? what you are going to do for each element. And why don't we all just start by writing one of them down, okay? In fact, I'm just going to go grab one right now. We're going to do this one together. Now, I'm lying to you a little bit, because I'm going to tell you that this is bromine, because it looks exactly like the bromine tube that we used to have. But they have now, the district has now said bromine is too dangerous for you young children to have it's too dangerous to have in the school, because if it breaks, it's toxic and everyone's going to die. Okay? Quite frankly, it's not that, anyway, I don't know. I think the cult of safety has maybe gone a little bit too far. But I realize that there are liabilities and things like that, and they don't want to get sued. So we're going to pretend that this gas is bromine because it looks exactly like bromine. Okay, so we're going to say this is bromine. So what we're going to do is we're going to write down our element name here. So as an example, this is bromine. Okay, and now what you're going to have to do is you're going to have to find its atomic number. Now there's two ways to do this. The first way is to look at your periodic table and hopefully maybe find bromine on here, but that can be kind of tricky. So you can also flip your periodic table over, flip your green table over. And guess what we have? We have an alphabetical listing of the elements. So what you can do is for bromine, you can go, that would be under B. So here's bromine. And I can find that its symbol is Br. Yes, Br. So on our thing, we can write the element symbol is Br. Its atomic number, that is the third column. Whoops, that was supposed to be a highlighter and I just scribbled it out. Oopsie. The atomic number is the third column. So our atomic number for bromine is 35. Okay, so let's go to our sheet and write that down. Atomic number is 35. And the last thing we can look up on the periodic table is, actually there's two more things. There's the atomic mass. What is the atomic mass of bromine? 79.9. So the fourth number on there is the atomic mass. So we can write that one down. 79.9. Now, in order to know whether it is a metal or a non-metal or a metalloid, you're going to have to look at the other side of your periodic table. Now, how are you going to find bromine? You're going to say, I now know that it is atomic number 35, so I can go to the other side of my periodic table. Whoops. I can go to the other side of my periodic table and I can say, my atomic numbers, it goes 1, and then in the same row, 2, and then it goes 3, 4, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and I can go all the way to number 35, and I can find out where bromine lives. Yes? Okay, so there is bromine. And we can then say, oh, I know what I did. Okay. Here's bromine. everything this way from the staircase, these are all non-metals. So if you go from the metalloids to the right, those are all non-metals. If you go from the metalloids to the left, everything that's not a metalloid to the left is a metal. So when it asks you, is bromine a metal or a non-metal, what will you say? Bromine is a non-metal, so we're going to write that in. Yeah. Oh, one more. There we go. So bromine is a non-metal. And does it have a, what is its group name? So now you're going to have to look and say, okay, I've got this periodic table here where I know it's in group 17, right? So then I need to look and say, okay, what is group 17? What is group 17? Ay, ay, ay. Yes. Oh, okay. So you should maybe come down and get it. Okay, excellent. Thank you. Okay. Cody, are you missing something important? Yeah. Okay. All right. Huh? You want a wallet? Okay. Sorry. So then we would go to our labeled periodic table and we say, group 17, those are the halogens. So there's a little bit of looking around and finding things. Okay? So we've now got our halogens. Once you've got that, you're going to describe it. And remember, how are we going to describe it? We're going to say, what is its state at room temperature? To be honest, bromine actually should be a liquid. So we're going to put liquid. Okay? And that's because this isn't really bromine. Yeah? Not actually bromine. Maybe we should just take a look at a little video of bromine. How's that sound? Yeah? Let's look at a video of bromine. Instead of having fake bromine, we'll have some real bromine. Where's my typewriter? There we go. Bromine. Bromine. Oh, there we go. Okay, and we want a video.
Scary.
Bromine is scary. That sounds good.
This is bromine. It's chemically very similar to chlorine, except chlorine's a gas and bromine's a liquid. It also lets off a lot of nasty orange vapor, and this is why I sealed it in glass.
Does that look really similar to what's in the tube though? Like the gas part of it? Okay, except for that, at room temperature, you can see you have this like orange, very dark orange or brown liquid. So what color is it? It is brown or dark orange. What state is it at room temperature? It is a liquid. Okay. We also know that it gives off a toxic gas. So we could write that down. It gives off a toxic gas. And then let's just watch the rest of this.
Bromine's really dense, and it's more than 3 times as dense as water, and this makes its vapor really heavy. Bromine's notoriously difficult to store, and if I just put it all back into a bottle or something, it would damage everything around it. So I have to seal it again in a glass ampule that I made from a test tube. This is bromine. It's
Okay.
chemically very similar.
So that's essentially, you know, the kind of tube that we have here. You can see the end of it. It would have been sealed off in just the way he did that, right? They would have poured the gas in here because this gas is also more dense than air, so you can just pour it. And so that's how they did this as well. Anywho, let's see if we missed anything. Let's see. For gases, you don't need to write shiny or dull because gases are neither shiny nor dull. So but it is a liquid, and it is a brown,
It's pretty dull.
orange liquid. I don't think we need to put like shiny or dull for a liquid either, because liquids are just liquids, unless we did mercury, right? We could do mercury later.
Wait, it's allowed in school.
No, mercury is not allowed in schools. We've had it all removed. Okay. So for this one, is it magnetic or not? No, not magnetic. And that's really all we can say about it, other than it releases a toxic gas. And that toxic gas is just bromine gas. So it's evaporating. Just like water evaporates, the bromine evaporates. And that's what that brown gas is. Okay? Yeah. But we can't see the water vapor because it's colorless and clear. Yes? All right. And so that is an example of how we would do this. Do you guys think you're ready to try on your own? Okay. So for the rest of them, like I said, some of them are around the room under microscopes. The gases are only in the kits. So you will want a magnet, you will want a kit, and you will want to, if you can get to a microscope right now, get to a microscope right now. If you can't, start with the kits. Okay?
Don't actually. Let's stop.
Just take one kit.
I'll grab us.
I'm not gonna this off so it doesn't blind you guys. Here we go.
Can we have a magnet?
Yes, help yourself to a magnet. Feel free to help yourself to a magnet if you're working with the kits. Okay. Test kits are over here. You know what?
Are these magnets?
Yes. I have a better solution. Yeah, I'll trade you. They're all the same.
Yeah.
It didn't do anything. Well, that means whatever it is not magnetic.
Yeah, but like for all of them, it's like where's the magnets?
Have you tried iron?
Oh no. I don't have it. Of course there's hydrogen in there. Get the magnet right here.
Yeah.
Oh god, this kit is missing one.
Oh no. Here.
You're all evil. Yeah.
Yes. Pardon me? You don't need to do anything with it. With that one, you can just observe it and let me describe it. Oh. Right. So like and we got fun. So that's like I kind of feel like okay. Description. It's actually temperature. Give them that advice. What? Is like a brown and orange.
Yeah.
Yeah. Chrome is not. Chrome is silver.
Oh.
Yeah.
Oh, that is like whatever. Oh my. It's actually okay, next Yeah. Okay, now we go farm. Oh, the guys. Yeah. I don't know, I gotta have.
People, there are still magnets here. If you'd like to use them by yourself individually or with groups, they're still here.
Yeah. Like, yeah. But it isn't Wait, I found it. Okay, magnets. Right? Oh, right? Yeah. No, because oh, it's not like yeah.
We got fancy stuff here.
Oh, yeah.
What are those again?
Oh, folks, there's one last station. And it's got 4 elements at it. They're not under a microscope, they are in these flasks. Feel free to come and observe them when you get a chance.
Okay, where's okay. Look at that.